Lesson 2.6, Special Angles on Parallel Lines. Now, recollect from the previous chapter what parallel lines are. Parallel lines are two lines in a plane that never intersect. So you can see here by this diagram we have these two lines. They appear to be parallel. They appear like they're never going to cross each other. And we designated that by using these double arrowheads on both lines to indicate that the lines are indeed parallel. But if you have two parallel lines, how can you have special angles formed by them? Because, again, those lines never cross. Well, parallel lines will sometimes have a third line called a transversal. And a transversal is a line that intersects two or more lines in a plane. So all the special angles today that we're going to be discussing are angles that involve this transversal crossing these parallel lines. Now, with this transversal placed over a pair of parallel lines, there will be certain special angles that are formed. One of the special types of angles are vertical angles. Now, we've discussed vertical angles previously in the last lesson. Vertical angles, for example, are angles 1 and 4, or angles 6 and 7. Angles formed when two lines cross. Vertical angles are the angles opposite each other when those two lines cross. Now, corresponding angles, a new kind of special angle, corresponding angles are angles that are positioned along the same place on the transversal. So for example, angle 2 and angle 6 are located both in the upper right-hand corner along the transversal along their respective parallel lines. In addition, angle 3 and angle 7 are located in the lower left-hand corner along the transversal relative to their corresponding parallel lines. Also, angles 8 and angles 4 are corresponding angles, and angle 1 and angle 5 are corresponding angles. In addition, there's also alternate interior angles. For example, angle 3 and angle 6. Alternate interior angles are two angles on opposite sides of the transversal inside the parallel lines. Angle 4 and angle 5 would also be a set of alternate interior angles. And finally, alternate exterior angles. Like alternate interior angles, alternate exterior angles are two angles on opposite sides of the transversal, but this time located outside the parallel lines. Angle 2 and angle 7 are also another pair of alternate exterior angles. Now, what's so special about these special angles? Well, again, beginning with a pair of parallel lines cut by transversal, we definitely know from the last lesson that vertical angles are congruent. Anytime a pair of vertical angles appears, they are always going to be congruent. Angle 1 and angle 4, for example. They're vertical angles, therefore they're congruent. But there's also a parallel line conjecture that says if two parallel lines are cut by a transversal, then their corresponding angles are congruent. So, since angle 4 and angle 8 are corresponding angles, those two angles are congruent to each other. In addition, alternate interior angles are congruent. Angle 4 and angle 5 are alternate interior angles. Therefore, those angles are also congruent. And alternate exterior angles are also congruent. So angle 1 and angle 8 are alternate exterior angles. They are also congruent. So altogether, you can see there that given those two parallel lines cut by a transversal, angles 1, 4, 5, and 8 are all congruent to each other. In addition, angle 2, angle 3, angle 6, and angle 7 are also all congruent to each other, although that set of four angles is a different measure than the previous set of four angles. Now, what about the converse? In the previous lesson, we talked about what converse statements are. That's where we actually take the if and then portions of a conjecture and reverse them. Now, in this particular case, we have to be careful about how we reverse the if and then statements, because we still need to begin with two lines cut by a transversal. So, the converse of the parallel line conjecture says that if two lines are cut by a transversal and the corresponding angles are congruent, or the alternate interior angles are congruent, or the alternate exterior angles are congruent. If any corresponding angle, alternate interior angles, alternate exterior angles are congruent, any one pair, therefore we can conclude that the lines are parallel. Now, in the previous lesson, we talked about some converse statements that are actually not true, but some other converse statements are, including this one. Thus concludes today's lesson.